Welcome to qnawire.
Okay, so for question 3, blue light of wavelengths, which is 440 nanometers, is incident on two slits separated by 0.3 millimeter. So for the first question, we need to determine the angular deflection to the center of third order bright band. So there's actually a formula for the angular deflection, which is sine theta m equals m lambda over d. And m here means the order, and we are looking for the angular deflection to the center of a third order bright band. So m is equal to 3. And the lambda is a wavelength. And we already know the wavelength from the question, which is 440 nanometer. And 1 nanometer is 10 to the negative 9 meter. So after all the conversion, we get at 440 nanometers equal to 4.4 times 10 to the negative 7 meter. And then d here is just the separation between two slits, which is 0.3 millimeter, and 1 millimeter is 10 to the negative 3 meter. So 0.3 millimeter is equal to 3 times 10 to the negative 4 meters. So we get all the data for different elements, and we get sine theta 3 equal to 3 times 4.4 times 10 to the negative 7 meter divided by 3 times negative 4 meter, and we get the value is 0.0044. And that's the value for angular deflection. But actually, we need to find the angles because we'll need it for later questions, and it won't hurt us to calculate the angle from sine function. All we need to do is just plug in the value we got from the previous equation into arcsine, or we call it inverse sine function, and we get the angle is 0.25 degree. And for question B, we need to find the spatial separation from the zeroth order band when a line is projected on the screen located 3 meters from the slits. And we are so lucky, and there's also a formula for such questions. So for the spatial separation from zeroth order to m order band, the formula is this: is ym equals to m times capital L times lambda divided by d, and m here is also means the order. And a capital L here means the distance from the slit to a screen. And it was given is 3 meters. Let's take a look. It says 3 meters from the slit, so it's 3 meters. And lambda is just the wavelength. We already got it, which is 4.4 times 10 to the negative 7 meter, which is 440 nanometers. And D is just a separation with two slits, which is 3 times 10 to the negative 4 meter, or 0.3 millimeters. The reason why we can convert to meters is just for the simplification for calculation, so we can calculate it easier. And that's for the first spatial separation from the zeroth order to the first order band, which is y1 here. So m here in this case is 1, and the rest is the same, which is the L here is the 3 meter, and the lambda is 4.4 times 10 to the negative 7 meter, and the D is 3 times 10 to the negative 4 meter. And we get y1 is equal to 0.0044 meter, which is 4.4 millimeter. And for y2, we simply just change the m value. And in this case, since it's y2, which means it's the second order band, and m just equal to 2. And the rest of the data is the same. And then we get the y2 is equal to 0.0088 meter, which is 8.8 millimeters. For y3, it's all we need to do is just change the m value, same from the previous one. So m here is equal to 3, and the rest of the data are the same as well. And we get y3, which is the spatial separation from zeroth order to third order band, is equal to 0.0132 meter, which is equal to 13.2 millimeter. For question C, we need to draw a sketch that schematically represents this situation and label all known distances and angles. So that's what I got. So we know the distance between slits and screen are 3 meters. So this is a capital L here. And the separation of two slits is just 0.3 millimeter, which is here. And we already calculate the spatial separation from 0 order to the n order. So y1 is just 4.4 millimeter, and y2 is 8.8 millimeter, and y3 is 13.2 millimeter. So that's all the spatial separation to different order bands from the zero span. And since we only calculate the angles of the angle deflection to the center of the third bright band, which is 0.25 degree here, which is the third angle here. So in order to complete the graph, we need to find the first angle and the second angle. And all we need to do is just plug into the equation from the first question, which sine theta m equal to m lambda over d, and change the m value since we're looking for the angular deflection to the first band and also the angular deflection to the center of the second band. And we get sine theta 1, so which is equal to 1 times 4.4 times 10 to the negative 7 meter divided by 3 times 10 to the negative 4 meter, which we got such value, and the angle is 0.084 degree for the first angle. Sine theta 2 is equal to 2 times 4.4 times 10 to the negative 7 meter divided by 3 times 10 to the negative 4 meters equal to 0.0293. And the angle for the second one is 0.168 degree. So far, the graph with all the informations we know from the questions. Thank you.